Hello, I've been digging into the MultiWii source code a little bit lately, further than just looking at the config file, and I managed to get support for using the nRF24L01 modules directly using the SPI of the flight controller board itself, and that's what we're looking at here. It's up and running on this one, and we'll take a look at that a little bit later, but first I wanted to give a little bit of background as to why this might be a good thing to do. And I first sort of thought of this when I was making the cheap-ass quadcopter a few months ago, and as we can see, we have in the upper left is the RF24 module there, and that's connected to the Arduino Pro Mini on the upper right with a bunch of wires, and this Pro Mini is here purely just to talk to the RF24 module and receive the radio data, and then it is connected to the flight controller over here, which is actually doing the stabilization of the aircraft while it's flying, and they're connected by a PPM connection so that the Pro Mini can tell this one, which is actually basically a Pro Mini as well, what to do. And as you can see, maybe there's two chips on these things here. This one, there's a big square chip in the middle, that's an ATmega328P chip, and then up there we have exactly the same chip. So there's a little bit of redundancy there, because the Pro Mini over here is not really doing much, because most of the work that's being done to process the radio signals that are coming in are actually being done by the RF24 module here. So this Pro Mini is purely there as a go-between between this module and this module. Now, this module is quite busy, but it's not busy enough that it couldn't do a little bit of communication, because there's the PPM communication going on there. And as I say, most of the work is being done by the RF24. So what I wanted to do is get rid of this in-between Pro Mini there. Or better still, just make this Pro Mini be the flight controller. So to look at that in a diagram, I made this little diagram here to help explain things, what's going on. So what we just looked at on the cheap-ass quadcopter there was basically this arrangement. The transmitter sends the instructions through the radio. The RF24 module here receives that, processes it all, does some clever stuff in this little chip, and then it talks through SPI, which is a digital interface and is very fast. And so this Pro Mini being the receiver, well, I guess these two boards here are the receiver together. They have digital information, and first things first, the flight controller over here, what we're trying to do is send the stick positions to the flight controller over here. And the end goal of what we're doing is, if we look at the MultiWii source code, we can see this little line. There is an array of integers, and that's the RC data that we eventually want to use. So that's digital data. So we start with our transmitter, and then we want to get to digital data on the flight controller. That's where we're going. So to get there, we are first getting digital data on the receiver, and then we send that, as I mentioned, through a PPM style connection. And that is, I'm calling it analog. It's not strictly analog here, because the way PPM works is we have signals like this. So this is just one wire. The PPM connection is just one wire, and the voltage on that wire is being raised and lowered. So it's not analog in the sense that there's varying voltages on this wire. It's just going up and down very quickly. But the reason I'm calling it analog is because the data that you put into this connection is not exactly the same as the data you get out, because it relies on this timer being used to switch this up and down. And then on this side, this guy has an interrupt which gets called each time this voltage changes. So the thing is that they're both relying on their timers to transfer this information accurately, and the timers are not always precise. So as you can see here, this whole thing is taking place within one frame of 20 milliseconds. So each of these up and downs are on the order of microseconds, and that timing is pretty hard to get accurate. So the data you put in is not exactly going to be the same as what you get out on this side. That's why I'm calling it analog. So anyway, yeah, we can see we're requiring use of a timer here, and we're requiring use of interrupts here. So it's a little bit of inefficiency to go through this path to get from digital to digital there. So that's the motivation for using this. So what we're trying to do is, if I rearrange this a little bit, we want to have this one be the receiver and the flight controller. Let's get rid of that. And he has digital information there. We never want to deal with analog or PPM or timers or that interrupt, and basically we don't want that. Get rid of all that stuff completely. So already you should be seeing that it's a fair bit more efficient just to do this. Now that's one thing, it's more efficient, less stuff on the board. Of course, one thing we will need here is a accelerometer gyroscope module. So you can't, obviously the Pro Mini on its own doesn't know anything about the orientation of the aircraft, so you will need to use accelerometer gyro. So you could do it like this, I guess, would be a little bit better way to do it. So let's do it that way. It doesn't really matter which way you do it, and you will need the SPI pins, of course, and we don't see a pin 13 on here anywhere, but if you look at this little thing here, it's a ISP header, so there is a pin 13 there if you want to try this with the board that I was using for the cheap-ass quadcopter build. Anyway, so apart from just being more efficient overall, one really nice thing about these transceivers is that they are actually transceivers. They're not just transmitters and receivers. They can send information back. So any information that this flight controller has, for example, basically anything you see in the MultiWii GUI can be sent back from this to your transmitter. And specifically what I've been using this for so far is the information that gets sent to the flight controller is throttle yaw pitch and roll, a couple of dials that I'm not actually using, and then we can use a byte for our some kind of switch data. So you can actually fit 8 bits of information into 1 byte like this. Because it's digital, you're going to get exactly the same information you sent coming out at the receiving end. So you should be able to see that you can get a lot of channels through this communication instead of just the 8, because when you're using PPM you're kind of limited to a maximum number of around about 8 is all you can feasibly do within 20 milliseconds if you still want to have a reasonable number of frames going through every second. But not so. With the nRF24 modules you can send 32 bytes of data, which could be 32 analog channels, or if you're using, for example, you're using bit flags like this switches one, that's 8 bits, or 8 like on-off switches like you have a switch on your transmitter. There could be 8 switches in 1 byte. So if all you ever have is just switches that go on and off, you could actually have 256 of those going through this communication channel. I might just mention at this point, I haven't actually successfully managed to send a 32 byte packet, but I have managed to do up to 24 byte packets, so I'm not sure what's up with that. But anyway, this is what I'm sending from the transmitter to the flight controller, so that's going over there. And then what I'm sending back, at least what I'll show you at the moment that I'm sending back, is you can send back in the AC payload, you can also send 32 bytes, I think. What I'm sending back at the moment is a lat long position, which I'm currently not using, but I'm just keeping it there so that I don't have to keep changing the sketch all the time. Heading, which is the yaw of the quadcopter, the pitch, the roll, the altitude in centimeters, and then also a byte for flags, which currently I'm just sending back whether the quad is armed or not. So that information can come from here and go over here. So then we have well, we still have that, don't we? Yeah. So then we have information from the transmitter on here, information from the quadcopter coming back there. Yeah, so hopefully you can see that that's a really useful feature to have. Unfortunately, the range of these RF modules is not really that great. You're stretching it to get to about 500 meters, I would think. But still, for shorter distances, it's quite a cool thing to be able to do. So anyway, let's have a look at this quadcopter. Actually, first, I should probably mention that what I've done here this is not the first time it's been done. In fact, I thought about doing this for quite a long time, but I put it off, and I just kept putting it off. And finally I saw this page here. This guy's done pretty much what I've done, but a slightly different way. And I looked through some of his code, and I thought, well, actually it's not super difficult. I'll give it a try. So I'd like to thank Mir Zeitlin for putting this code up and giving me the little kick that I needed to get started. And he's done a very similar thing to me, but I'm not sure how much of the details I need to get into. But just going back to my diagrams for a second, these are the conditions for the setup that I've made, because there are some quite strict conditions that you start to bump into when you're using at least in my case, a Pro Mini, for both the flight control and the radio communication. And the main one is that it's only going to be usable for aircraft that are using 4 motors. So that's going to be actually I had that here, where is that? Yeah, so it's only for 328p configurations and only for 4 motors. So specifically, what that means is, if you look on the MultiWii website, you'll see all the configurations that there are. On the right side here we have Arduino Mega, so all these ones are for Arduino Mega, and that's not going to be applicable to what I've done. On the left side we have for Arduino 328p, and anything that's only using 4 motors I think should be okay to use. So that would be a tricopter, quadcopter X, I know that one's okay for sure, quadcopter Plus, and Y4. Anything else is not going to work, just because of the number of timers on the Pro Mini are not enough to handle it. And there's not that many pins either, really. So yeah, that's the first major caveat, I guess you could say. Only quads. So the reason for that is that we need to use some of these pins for SPI, for hardware SPI. The next thing that you'll probably want to make sure of is that you're using a 5 volt or 16 megahertz Arduino. I haven't tried it with a 3 volt 8 megahertz Arduino, but I have a feeling it would be a bit on the slow side to handle everything and keep it flying nicely. I don't know though, might be okay, no idea. But I do know at least that a 16 megahertz Arduino will be fine. And for other flight controllers like like this one, as I mentioned before, you'll need to be able to use the hardware SPI pins, and not all flight controller boards will have that available, so you'll probably need to check on that. Specifically, those are pins 10, 11, 12 and 13. If you're using AC payloads at any distance, you'll want to be using a high power RF24 type. If you want to do this within, say, about 50 meters or so, should be fine to use just the regular one, the PCB antenna type. But I haven't really tried that, so I'm not sure how much it would slow things down, because theoretically the radio communication would slow down a little bit, because the transmitter waits for an acknowledgement for each packet that it sends before sending the next one, up to a limit. Like there's a limit of 15 milliseconds or something, or 15 retries or something like that. But yeah, if you're using it any further than about 50 meters, you'd want to have a high power RF24. The source code that I started with to make this was, I checked this out from the development version, or the development revision of Subversion on January 17th, so that's revision 1737. Not that long ago, but the reason I mentioned this is that it's not a it's not like a production release. I don't think any of this open source stuff is really, you could really call it a production release. It hasn't been like super tested or anything like that, but it's not an official release that I've based this on. So what this will be is the MultiWii 2.4 code. Sooner or later they'll release it as 2.4, I think. So if there are any problems in that have come into the MultiWii source code since the official release of 2.3, this source code that I've used will have those problems. If anybody wants the diff for this, I can give you the diff. Otherwise, in the link in the description, I'll just upload the whole source code as a zip. Alright, so if you want to use this, there are a few considerations that you'll need to keep in mind. One is that I've only checked this with the Greg Copeland what's the word? Fork. The Greg Copeland fork of the RF24. Oops. Oh, okay, there it is. So this is the source code that I've used for the RF24 library. I actually had a response from Greg Copeland a while ago saying that his fork is not so great, there's problems with it, and I should use another one by somebody who, sorry I forget the name, I'll put this as an annotation up here. However, I tried the library that he recommended and I couldn't get ACK payloads working with it, so rather than spend a while, and I remember from my last experience trying to figure out what problems were with that, it took me an entire day. So I decided rather than fiddle around with that, I'll just keep using the Greg Copeland fork because that's working fine. So anyway, the motors, as I mentioned, will be changed. So what you see in the MultiWii, what you see on this page here, instead of using 3, 9, 10 and 11, you'll be using instead of 9, 10, 11 and 3, you'll be using 9, 6, 5 and 3. And the nRF24 connections, as I mentioned, we need 11, 12 and 13, and I'm using 7 and 8 for the chip enable and the clock select not. You should be able to change those, the 7 and 8 that is, you should be able to change those in this file here. If we look at that, right at the top here we have this here. So I think you should be able to change these ones without too much trouble. Now as I whoops, let's go back to the header file. So the file we're looking at here, it's actually not too clear, but we're looking at the header file of this. So it's nRF24Rx.h. That's the file we're looking at here. Unfortunately, it's a little bit off the screen. I can't quite show you that. But the packet structures that I have at the moment are the ones that I just showed you. So that's throttle your pitch and roll, dial switches, and then the ACK payload is that's what I just showed you. So if we look in the CPP file here, we'll see some familiar stuff. If you've used the RF24 library, you'll see, where is it? So we start off things like this. We do radio begin, set the data rate. So your transmitter that you make will have to be matching these settings here, these settings there. And of course, I'm not going to explain all that here, but I've explained it in my cheap-ass quadcopter build series if you want to look at how that works. But anyway, what's relevant for this particular video is what we're putting into the ACK payload, and that happens here. And as you can see, I'm just putting in some hard-coded lat longs at the moment. I haven't got around to making any GPS readings for this working. And then I found that we can get the yaw and the pitch and the roll from these variables, and also the altitude is this is the altitude in centimeters, and then for the flags, there's this very inconveniently named variable f. The variable f is actually a global variable that the MultiWii source code is using for a structure that holds the flags, the current state of the app. Let's see if we can find that. It would be in here somewhere, wouldn't it? Types. Oh no, sorry, it's in. Alright, never mind. But anyway, I was a little surprised to see that, but this variable f is a global variable. Anyway, and that holds the flags. So we're just memcopying the first byte of that into our payload flags variable. And it turns out that the second bit of this is telling us whether the quadcopter is armed or not. Actually, I will just find that. Just give me a moment to find that. Okay, this is the structure here that holds the status of various things that the MultiWii is doing. So this, you can see here the second bit is armed, and that's what I'm using on the receiver side to tell my Android app whether the quadcopter is armed or not. So you can see also here whether it's in angle mode or horizon mode, barometers being used or whatever. So you can get these and send that back to your transmitter. Anyway, so let's have a look at the quadcopter itself. There's not really a whole lot to look at, but I'll just have to squash it up in front of the camera here and see if we can get it to focus, because I took a lot of nice photos as I was building this to explain what I was doing, and then I unfortunately forgot to take the photos off my Nexus 7 before I reflashed it to update to Android Lollipop, which is a bit of a bummer, so those photos are gone. But anyway, you can see on the, starting from the top left, we have the Pro Mini. That's a 5-volt one, of course. Then to the right of that, we have one of these. It's a GY80. Maybe you can see that there. It's a GY80, and that has an accelerometer, gyroscope, compass, and a barometer. I don't really need all of those, but I had it sitting there unused for a while, so I put that in here. Down here we have the RF24 module, high power variant, and in the bottom left I have a little voltage step down regulator, and that's taking voltage from the battery directly, which is going to be either about 7 to 8 volts or 11 to 12 volts, whatever. So that's one of these things, and that's going to step the power down to 3 volts for the RF24 module. And I have a little capacitor across the ground and VCC of the RF24 module. And coming in at the top here, I have 5 volts coming from one of the ESCs, and that's powering the Arduino and the IMU there. So you can see on the side here the white wires are the ESC wires, and they are going to pins 3, 5, 6 and 9. So that's how that all works. And the nice thing about this is it's quite nice and compact. In fact, if I... oh, there's a wire sticking up there, but apart from the pins here for the Pro Mini connection, FTDI connection, it's all fitting inside that case there, which is about a 12 millimeters high or so. Oh, what's that? Oh, the antenna doesn't fit in the case. No, it doesn't. That's kind of a bummer, actually. I've found out already how soft this wire is and how easy it bends when you have a crash. I've actually managed to bend it back quite well this time. But yeah, definitely would be nice to have something other than this. It also wobbles a little bit, which can sort of interfere with the gyroscope a tiny bit. But all in all, it's not too bad. And it's good to have the peace of mind that you're going to be able to communicate properly with it when it starts getting at a distance to you. So anyway, that's that. the other thing that's a bit annoying about the antenna is that you sort of need to bring this little cable from there, and you need to put it through the bottom and then bring it back up again like that. So it's this little black wire here, and then it kind of sticks up at the bottom. So I'm gonna have to figure out a better way to get a good antenna on here. It would be nice if there was one that was only this part, so if it was just cut off here and connected somehow a little bit more compact would be nice. On the bottom here you can see I've opted not to use a power distribution board this time. I thought I'd try just wiring everything up directly. Yes, there's bare pieces of wire sticking out there. It's not very safe, I know, but works okay. Not much else to say about that really. There's a little camera on there. This is one of the small cameras that I got for FPV, so that's just sitting on there nice and secure. It's not going to be broken off anymore. I've had enough of that. So that's just sitting here. It's disconnected at the moment, but if I want to connect that, I just bring that the brown, the red and the yellow wire there, this one, I just bring that through to the top and I hook up my little FPV unit that I made. So I just put this together from the components that you can buy separately, bits of stuff off Banggood, and on there we have another voltage step down converter, actually two of them, one for the camera and one for the transmitter, some honking big caps that we're recommended to use, and the little plug that goes into the camera that we just saw. So that unfortunately I have to take the antenna off to use it, but because everything fits inside there nice and flat, and this is actually, get that out of the way, you can see that this is actually not protruding below the mounting points there. I can put this on there and everything just sits in there nice without the top touching the bottom, although of course I will want to get some heat shrink and shrink wrap this nicely in the future. Just to demonstrate what that looks like. So that's the whole thing there. It's pretty compact, and this section here weighs 24 grams, so that's a nice light FPV setup. I haven't really used it that much. Haven't really had that great weather here lately. But anyway, to get back on with the the main story. So the receiving end of this, I've been working on that as well. I actually finished this quad about a week ago, and I've been working on the Android side of it a little bit since then. But what we have on the receiver side is this, and this is my cheap-ass transmitter, and this connects, there's a Pro Mini inside there, and that connects to the tablet through here. And just get everything working. Just show you how this looks before I start the quad up. This is just stuck on here with a large block of foam that I cut to just so that I could zip tie it all together. But it's not very stable, and if you're not holding it vertically, it flops open like that, so it's not very good. And these wires dangling around here are a bit of a pain in the ass, so I really want to get a better setup than this eventually. And I received something in the mail today that may help a lot with that. Details to come. But, oh, okay, so I think probably most people watching this video have already seen this app, so they know roughly what it is. This is a camera in the bottom right. There's a Google map in here, and this is just centered on the area down by the river where I do a lot of testing. So if you have a Wi-Fi point there, like I have in my phone, you can update this map anywhere. But what we're really interested in is the bit here with these funny triangles, and that is the pitch. No, sorry, starting from the left, it is the roll, the pitch and the heading of the quadcopter. And in the bottom left we have the positions of the sticks, and then to the left of that the red bar there is showing an indication of how many packets per second have been received, acknowledged rather. And let's see what that does when we connect it up. It's a bit ornery, this app, though. It doesn't like to... The only way it works is if I start it up by plugging in the transmitter. So now we should see, when I move the sticks, you'll see the sticks moving there, like that. And notice when I move it to move the throttle stick to the bottom right, nothing happens. Now when I connect the quad up, you see the heading change, and when I move the quad we'll see the blue arrow moving. When I pitch it forwards, we'll see the pitch go forwards and back. Let me see if I can hold this a little bit better. So it's pitch forwards, forwards, back, roll to the left, roll to the right. So this is basically just sending the information that you see in the MultiWii GUI back to the transmitter. And of course and you can see in the upper right there, I have altitude. Let's see if I can make that do something. So if I lift this above my head, altitude goes up to 1.5-ish. It's not very stable though, is it? Now if I put it back here, we should see it's lower. Okay, and the packets per second is fully green there. I made it so that the top of that bar is 100 packets per second. Anything less than, anything more than 100 packets per second will just keep showing a full bar. So now, when I move my stick to the bottom right, we'll see the outline of the stick boxes go red, which means that the quad is armed. So I can see on my transmitter whether it's armed or not, which is quite handy because there's nothing showing on here, which is a bit of a bummer. So anyway, I can see that on my transmitter anytime now. Anyway, that's everything, I think. So I did a little test flight of this today, but the weather was very, very cold and very, very windy, so it didn't really go too well. But I'll show you a little bit of that footage anyway, just because it's there to show. Unfortunately, the camera view is quite a bit behind the view at the top. As you can see here, when I move the quad with my hand, the camera is probably about, I'd say, over half a second behind. So as I'm flying it here, you can see in advance, if you look at the top screen, you can see in advance what the quad is about to do. And it's a little bit hard to see here against the grass, so I'll fast forward to where I was flying it a little bit more above the horizon. Let me also turn the volume down because the wind was making things rather noisy. So you can see I'm trying to make some violent left and right movements so that we can see the relation between what the quad's doing in the camera frame and what the telemetry is telling us it's doing. But I didn't realize that the delay was going to be so bad, and also it was really, really windy, as you can hear, and pretty cold. So after about 4 minutes of this, I had to actually stop because my hands were just getting too cold. So it wasn't such a great day for flying. I probably shouldn't have even bothered to go down there at all, really, but you can see that at least from this, you can tell that the telemetry is working okay. And if it wasn't so windy, it would be flying much nicer. Plus the other thing was it's really hard to hold that transmitter and point the camera and do everything at the same time. But anyway, that's what it looks like. So there you go. It's not a very good demonstration, but there's not really anything more to demonstrate other than what we're seeing here. So yeah, it doesn't really make much difference whether it's outside or not. But I've actually been flying this quad using this radio connection, that is the AC payload and everything, for about a week and a half, I think, maybe 5 or 6 batteries to be exact. And I haven't noticed any major issues with it. The response seems to be pretty good. Mind you, I'm using the high power RF24 in there as I recommended. So that's about all I was going to say. But there's one thing that I thought I should mention, just in case somebody does use this source code. When you download this and try and compile it first off, you'll see the standard message that you get when you get the ordinary MultiWii source code. The number of motors is not set. Most likely you have not defined any type of multicopter. So what I've done is I've tried to keep it as standard as possible. Like, I've tried to make it so that my changes are not messing anything up with the ordinary MultiWii code. So I've put if-def statements around everything that I've changed. So I'm hoping, although I haven't really checked, but I'm hoping that as long as you don't define what I'm just about to show you, then it should function exactly the same as the ordinary MultiWii source code. So for my case, what I do is I define quad X, and then fortunately there's already a usage option for the GY80, which was what I'm using, so I do that. Now if I compile like that, that's enough to get it running with the normal GY80, with the regular MultiWii radio protocol, and that's 17 kilobytes. So they've been working on this a bit to keep that down. I think it used to be larger than that. Now if you search in this file for RF24, you'll see this section here. So I should have mentioned this before, but you need to define this or uncomment that so that it's defined, and that will bring into play all of the changes that I've made. So if we compile that now, we'll see it's a bit bigger. So it's 20 kilobytes now, still not too bad. And of course you'll need to get the oops, where are we? The Greg Copeland, you'll need to have that library installed in your Arduino installation to use it. So yeah, if anybody tries using this, let me know. It'd be interesting to see how it goes. But this video is way too long to say anymore, so yeah, put your comments below if there's anything interesting you have to say. See you later. Thanks for watching.